Hey James and Juliana, today is Monday, late Monday, and as you can probably see, I got a haircut, and also I just got out of the shower, and that is because I just got back from my baseball game, which didn't end till 10:30, and we didn't do that well. We gave up 4 runs in one play. Yeah, the hit that should have been a double at most ended up being a homer because we made four overthrows. Four. Not too good. Not too good. Or was it three? Anyway, it wasn't good. But I'm not going to ramble on to you about that. Instead, I'm going to ramble to you about gravitational waves because that was a thing that was discovered, and I'm kind of behind on that. And James, you probably already know a lot about this, but for Juliana, I will go over. So, a while back, a lab, I forget the name of it in particular, but anyway, there's this lab, and they're studying all sorts of waves in the universe because, according to Einstein's theories and all this stuff, the universe is technically a series of waves, and this sort of proved it because this showed gravity as a wave because this is the first sign of gravitational waves I think we've ever recorded, and essentially they had two mirrors, I believe, and they were detecting like all sorts of changes. And the gravitational waves altered how long and wide they, long and wide they were. I believe is how it worked, and it changed them by 1/10 of an proton or something like that. Anyway, very, very, very small amount. Couldn't do anything really, but it still proved it. And this proved a lot of Einstein's theories. His last theory, I believe. And it basically showed that through math, you can predict something that will be discovered 100 years from now. But essentially, the way gravity now is believed to work is gravity is really distortions in space-time. So say I had a sheet of like paper or something that would bend, and say I had like a giant sheet of like plastic or something that was being held out and was strong enough to hold the weight of a bowling ball. Well, say I put the bowling ball in the middle, it would put a dip, and that's sort of the distortion in space-time a planet makes. And now, say I were to spin a marble around that, and the marble infinitely had that amount of propulsion. That's how orbits are made. You're spinning around it because of the distortion of space-time. Since you have that infinite amount of, not infinite, but since you have that constant amount of energy, because in space, since there's nothing pulling you in, and if you go to a certain angle, that energy will keep you going. That's how orbits work, and the way the moon works, I believe, is that what little it pulls us, because we pull the Earth pulls the sun a little bit, very, very small amount, so we don't really account for it, but it does. And the way the moon works is, I believe, it pulls at us, and that's why our waves and tides and stuff happen. So yeah, this is sort of a quick crash course through that because it's a lot more complicated and very complex, and PBS has a thing called Spacetime or something like that. Really awesome show. Just look at gravitational waves, and it's one of the first videos you see. And they're really cool. Really, like, mind explosion-y stuff. Very complex math, but really cool. So go ahead and check those out. And James, I'll see you Thursday. And Juliana, I will see you Saturday.